Okay, take your attendance first, as usual. Okay, guys. Okay, good. So let's start our lessons today. Okay. Just one information. Do you receive any notice that you'll be starting your practical next week? Anybody?
Yeah.
Okay. So I'll send the soft copy of the practical manual to you later. I post it in WhatsApp, so you just print out for your next week. Okay, so I think you'll be having practical twice a week, right? Wednesday and Saturdays. Okay, so no choice. I think we need to rush. Okay, so let's get back to the topic we learned the last class. So temperature, right? Okay, so just a short recap what we learned. So yesterday we talked about this is the third topic of your A2. So first we talk about thermal equilibrium, what is meant by thermal equilibrium, and today we're going to discuss about the temperature scale and practical thermometers. So what is thermal equilibrium? When two bodies in contact, when object of substance are contact such that they're able to flow from one object to substance to another object. What is meant by thermal equilibrium? When two bodies in thermal contact, the net flow of heat is zero, then we say it achieves thermal equilibrium. Okay, when two bodies achieve thermal equilibrium means they must have same temperature. Okay. So yeah, so temperature scale, how do you create a temperature scale? These are the three steps. You need to find a thermometric property which varies monotonically with temperature to be identified. Then two fixed point is used to calculate the thermometric property, to measure the thermometric property. Then we create a numerical scale. Okay. These are the three things they will ask, very important. What are the steps to create a temperature scale? So find a thermometric property. Don't stop there. You have to say a thermometric property that varies monotonically. Thermometric property that physically quantity that is changed monotonically is used. Okay, not necessarily linear. Monotonic means if the graph is curved also is fine, but preferably linear. But we don't have one. We don't have linear one. Normally it's little curve. Okay, the length of the mercury expansion, the length also is not perfectly linear. Okay. So then I introduce with it 4 types of thermometers. Today our lesson is going to go in depth about these 4. Two fixed point, melting point and boiling point is used. Melting point of ice and boiling point of water is used. Wide use because it's easily reproducible. Because every time very easy we can get 0 degrees Celsius. We know when the temperature is 0 degrees Celsius, when we see ice is melting. Okay, so easily reproduced and can be precisely reproduced. Okay, so divide, then we get these equations. Okay, so that day we stop here, right? So the X belongs to for mercury it will be L, for resistance will be R, for a thermometer which measures pressure it's going to be P, the sign. Common we write X. Okay, so today we're going to discuss about practical thermometer. Okay, for that we go to the PowerPoint again. Okay, so after we fix these three, numerical scale done. Okay, so yeah, we're done with this. Okay, before we go to the practical thermometer, there are three scales of temperature is used around the world: Fahrenheit, Celsius, Kelvin. Fahrenheit maybe in US use a lot, but your syllabus we only talk about Celsius and Kelvin. Okay, I think you are quite familiar with these two, right? But out of these three, which scale is the SI unit for temperature? Of course, Kelvin. Kelvin is the SI unit for temperature. Okay. So Fahrenheit used in US a lot. German scientists. We are not going to go in depth about it, but just aware that the existence of one scale called Fahrenheit. It's not in your syllabus, so I'm not going to go through a lot about this. So next is Celsius. Celsius is the one quite famous. The one we did earlier. We put the boiling point and what we call melting point of ice and boiling point to 100 degrees of interval. That's called centigrade scale. A Swedish astronomer is invented in centigrade scale in 1742. Celsius chose the melting point and boiling point as two reference temperature. The Celsius divide the difference between them into 100. Thus, the name centi, meaning 100, grade, meaning degrees, is used. Yeah. So the Celsius first is they call it centigrade scale. Later they put it as a Celsius scale. Okay. But then later, when they use gas experiment, the gas experiment, the volume of gas versus temperature, when they plot a graph, they found that the volume of the gas expected to be 0 at negative 273. Okay, it's called absolute zero, right? Absolute zero temperature. So to be more in depth, in your O levels, it was negative 273. But in A levels now, we go more precisely. We go for negative 273.15. Okay. So the temperature is quite unique because not only volume becomes 0 at that temperature, the pressure versus temperature graph also for a gas, the pressure tend to become 0 at negative 273.15. So Kelvin introduced another scale. The negative 273 become like 0 unit. So they introduce Kelvin scale. So negative 273 is stated to be as 0 Kelvin, and so on. Okay. So the Kelvin scale is based on an idea of absolute zero. Okay, the theoretical temperature which all molecules motion stops and no energy can be detected on the molecules. Okay, and the absolute zero value is found to be negative 273.15. For A2, remember, don't use your O level. O level only negative 273, but A levels negative 273.15. Okay. The Kelvin scale is used same unit as division as the Celsius scale. Okay. Yeah. So this is Kelvin scale. Okay. Now recall back. You should know how to change Kelvin to degree Celsius to Kelvin. So degree Celsius, you want to change to Kelvin, just plus 273.15. Okay. Don't only not 273 only, 273.15. These are the three scales circulating now. Any questions so far? Okay, I believe what I discussed just now is all looks familiar. Just a little addition. What is the addition? The 273.15 is the addition. And yeah, that's all. Nothing else. I believe you heard of Kelvin and Celsius scales. Okay. Fahrenheit, just for your understanding. Okay. Okay, now let's we go to the type of thermometers. Okay, the many type of thermometers. We're going to see what is the pro and con. What is the good and bad about that thermometer? Okay, so in this diagram, very difficult to differentiate between thermocouple and resistance thermometer. First is mercury in glass thermometer is the bottom. This picture you have seen this in the clinics. Second is the gas thermometer on top here. With a flask filled with gas, and there is a manometer. Okay, it's a gas thermometer. And third is the electric thermometers, thermocouple and resistance. This one, the 0.85, this diagram, and the other one also can consider as a thermocouple and resistance thermometer. Okay, this also thermocouple. Okay, and finally, the pyrometer is actually to find temperature more than very high temperatures. Is to measure very high temperature, we use pyrometer, but it's not in your syllabus. Just I put it here as extra knowledge. Okay. Your syllabus, you need to know the first four, the pro and con. Okay, first, let's see go about mercury in glass thermometer. So, in what are the thermometric properties used in mercury in glass? Length. Length of the mercury is the thermometric property. Okay, what is thermometric property means? What is thermometric property? A property that varies monotonically with temperature. Is thermometric property. Here is the length of the mercury column. Okay, so of course this is the equation to be used. L theta minus L naught over L100 minus L naught times 100 degrees Celsius will give you the temperature of the body. Okay, so you want to use this. I think we discussed this earlier. Find the L naught, find the L100 first. L naught, get it, put in the ice bath. L100 into the boiling water, boiling point of the water. Then L theta, find the length in the theta, the body where you want to find the temperature, and we use this formula. Okay. So before we go plus and minus, the good thing about this thermometer is it's very easy to use. Okay, very easy to use. Mercury in glass is, if I go few slides further, the first point, the mercury in glass. This table you have to memorize. Pro and con, the advantage and disadvantages. The mercury in glass, the advantage is portable, very easy to carry. It's very small. Direct reading, yes. Just directly they can read from the scale stated on the thermometer. Okay. Second, this is the advantages. The disadvantages, which we never knew before, is of course is small, not very accurate. Okay. Out of all the thermometers, the most less accurate thermometer is mercury in glass. Okay. The doctor using a less accurate thermometer. Okay. Because he just want a rough temperature of the body. Out of these other three are more accurate than the mercury in glass. Okay, so this is the advantage and disadvantage for mercury in glass. What is the thermometric property used in mercury in glass? The length of the mercury column. The length is the thermometric property, and the range of mercury in glass found to be up to 500 degrees Celsius. But the quite common you circulated in our lab is less than 100 degrees, around 100 degrees Celsius, right? Okay.
Sir.
Yep.
Do we need to know the temperature range?
Yeah, you have to know roughly. Okay. But so far, not even once they ask about the range. They ask about the advantage and disadvantage. Okay. Okay, so that's the first one. Okay, next. This is gas thermometer. We call constant volume gas thermometer. There are two types. Okay, on top, there is a flask where contains a gas. The gas volume is kept constant. It connected to a manometer. I believe in O levels we learn about manometer. Manometer got mercury column. So when the temperature change, the temperature of the gas change, the pressure going to change accordingly. Okay. Or the bottom. This is another constant volume gas thermometer. The flask kept some gas at a constant volume, never expand, connected to a manometer here, analog manometer. Okay, so you want to measure the temperature of this water. You have to put this flask into this water, okay, and measure the pressure. Okay, measure the pressure. Okay, so this type of thermometer, this thermometer is got advantage and disadvantage as usual. The advantage is out of all the thermometers, the most accurate thermometer is constant volume gas thermometer. This is the most accurate thermometer. Okay, you want to get the best temperature of any body, the best is constant volume gas thermometer. Okay, the gas inside the flask change its pressure very accurately to the temperature. So quite reliable thermometer. Okay, that's one advantage. But disadvantage is it's bulky. Okay, you can't use this. You can't use this flask to get the temperature of a small water droplet on a leaf. You know, on a leaf. Let's say at a tree, you can see after raining there's, let's say, a small water droplet on the leaf. You want to find the temperature of that water. Okay, you can't use this. You can't use this because it's very bulky. Okay, that's one disadvantage. Okay, let's say I go back to the table here. So the constant volume gas thermometer. The range is quite wide, up to 1500 degrees Celsius. Very wide range, very accurate, very sensitive, very accurate. Accuracy is the top in this range out of these four. Disadvantage, cumbersome. The bulb may have a very huge, very inconvenient and slow to use. Very inconvenient because let's say you want to use constant volume gas to find the temperature of your body. How are you going to use it? So the patient need to hug the flask. Okay, so it's not very convenient, not very convenient, and combustion is very big. Okay, so that's a problem of constant volume gas, and constant volume gas you can't carry from one place to another because it's bulky. So constant volume gas is used where? Currently, constant volume gas thermometer used for like a city temperature. Okay, you want to find a city temperature, Cal, Sydney, Singapore. The city temperature, the average temperature is calculated by using a constant volume gas thermometer. We just put it on a table. We never displace it anywhere. We just keep it there, so you get the temperature of the city accurately. That's the use of constant volume gas thermometer. Okay, so constant volume gas thermometer. What type of thermometric property use? Mercury in glass, length. Constant volume gas thermometer, what thermometric property use? Pressure. It measures pressure. Right. So I go back to this formula. This table, this paragraph, I'll get back to you later after we've done towards the end. I get back here. But currently, the formula you're supposed to use here is what? You can include that. The temperature is equals to P theta minus P naught over P 100 minus P naught times 100 degrees Celsius. Okay, this is the equation to be used. Okay, this one will be used later. Okay, for time being, you don't need to know this yet. Okay, yeah. So that's constant volume gas thermometer. One of the best, but unfortunately, it's quite bulky. Okay, that's the disadvantage of this thermometer. Any questions? Okay. Maybe a short while, maybe I can show you one video for this, just a short one. Okay, I don't know. I have to go on the. Okay, so let me show you one. So this is one of the. It's a constant volume gas thermometer. Have a look. Okay, just a small picture for you. Okay.
Welcome viewers. Today we will gonna talk about constant volume gas thermometer.
Okay. Sorry. Yeah. So just now you see the just now the video. Okay. You can clearly can see the disadvantage. So what's the disadvantage? Is bulky. Okay. So you have to, let's say you want to have a cup of water. You want to the flask need to be can be fit into that the flask. Then only you can measure the temperature of that liquid. If it's too small, then cannot fit in. Then you can't use this thermometer. Okay. Okay. So this is gas thermometer. Okay. Next, go. This is the I can say out of this 4 thermometer, the most glamorous, or I can say the most glamour and most famous one, and very focused in exam question. They like to ask question which type of thermometer is thermocouple. Okay. Okay, thermocouple. As I said, what is thermocouple? Okay, for to understand the thermocouple, I need to draw a picture here. What is thermocouple? Thermocouple thermometer consists of two wires of different metal joined at each end, like this. Okay, there are two wires. Lead copper wire. There is a lead copper wire. Like for example, let me show you. I draw. Okay, the rough sketch of thermocouple is like this. Okay, you can draw one. Okay, this is a thermocouple. Okay, I can say this is the wire A. This also wire A. This is wire B. Different metal. Different why the A. The top is the made of metal A. The bottom is made of metal B. Okay. Then let's say you put a beaker which has a temperature of 0 degrees Celsius. You put a beaker here with another liquid with, let's say, it's 100 degrees Celsius. A voltage will be generated between these two junctions. Okay. There is a theory behind this. When two different metal wire was attached at two junction and they exposed to a two different temperature, it seems the electron will start to experience a certain kind of a voltage between the junction and makes the electron to start to flow. Okay, I think a generating of current. Okay, but yeah, so when two different metal wires connected at two different junction and connected at the junction, okay, they're connected each other at the junction, two junctions. and the two junctions exposed to two different temperature, a voltage, it seems, will be created in the circuit. And that voltage is not, of course, can't use to light a light bulb, because the voltage going to be in a millivolt range, very small, okay, very small. But later they found that this voltage reading is very useful to measure temperature. They found that this voltage reading, this voltage looks like quite proportional to the temperature, monotonically changed with temperature. Okay, so they said, okay, this voltage reading can be used as a thermometric property for this type of thermometer. Okay, so they found if the temperature difference is year 0, year 100, let's say give 5 millivolt. When this 100 they change, let's say 50 degrees Celsius, 0 to 50, it give 2.5 millivolt. So the voltage change proportional to the temperature difference. Okay, this called thermocouple. Okay, this called thermocouple. It's called thermocouple. Thermocouple is a type of thermometer used what as a thermometric property? The potential difference. The potential difference between the two junctions. Okay, the potential difference used as a thermometric property in this type of thermometer. Okay, so it's going to look like this. Okay, it's simply going to look like this. Here inside they already have the two junctions, two type of wires connected here. Okay, so yeah. So now let me go a little further about thermocouple, because in exam they'll ask a lot about this. Okay. Okay, let me clear this. Sorry. Okay. So I draw one. Okay. So 0 degrees Celsius, 100 degrees Celsius. Okay. Just now, the mercury in glass, this thermometer, you want to find the temperature of a body which is theta. So what you have to do first, you have to put this thermometer into the ice bath, 0 degrees Celsius, you get L0, then you put it at boiling water, 100, L100, then you put into the body, which is at a temperature theta, so you get L theta, then use the formula to find the temperature, right? L theta minus L naught, L100 minus L naught times 100 degrees Celsius. Okay, so you need to do 3 times. You have to put in the ice bath, you need to put the boiling water, then later you put at theta, then you get the temperature. Okay, but thermocouple won't give you the in this case V voltage, the V naught, V100, V theta. Okay, let's say you want to find the temperature of the body theta, we need to find the V naught, V100, V theta. Thermocouple doesn't give V naught alone, it gives the differences. For example, here, let's say you got 5 millivolt. Yeah, you put 0 on the left and 100 degrees Celsius of okay, material, and on your right. So let's say it gives 5 millivolt. This 5 millivolt is actually what? This 5 millivolt is actually V100 minus V0. So give the differences one shot. It doesn't give V naught alone, like mercury. Mercury, like you put in the ice bath, it just gives L naught. But here it gives the differences. V100 minus V naught, 5 millivolt. Okay. So what is the formula used to find the temperature here? Theta equals to V theta minus V naught over V100 minus V naught times 100 degrees Celsius, right? So when you put 0 and 100, you get V100 minus V naught already. Okay. In this case, V100 minus V naught is 5 millivolt. Okay, let's say I give you the value 5 millivolt. Okay. Now what do? You want to find the temperature of the theta. So what do you need to find now? You need to find V theta. You need to find V theta minus V0. So what do you do? Remove the 100 degrees Celsius now. Don't put the 100 degrees Celsius. Put the substance which the temperature you like to look for. Let's say the theta here. So the 0 don't do anything. 0 leave it there. The 100 degrees Celsius change to the body you want to measure temperature theta, then the millivolt going to change accordingly. Let's say it changed to 5 millivolt, change to, let's say, become 2 millivolt. So conclusion is what? The 2 millivolt is actually what? 2 millivolt is actually V theta minus V0. So you get the V theta minus V0. So now you can find the temperature theta already. So what is theta? Theta is V theta minus V0 is 2 millivolt. P100 minus V0 is 5 millivolt times 100 degrees Celsius ratio. So you get the answer. Okay, 40 degrees Celsius. The theta expected to be 40 degrees Celsius. Okay, so this is how we calculate the temperature by using a thermocouple. Okay, thermocouple made of two different wires. The junction connected at a two different temperature. Science found that a small potential difference will be generated. So the potential difference is found to be quite monotonically changed with temperature, and it's quite accurate. But the voltage is very small. Voltage is very small, but very helpful to find the temperature of the body. Okay, thermocouple is quite unique compared to other thermometer because it doesn't give the value of the L0, L100 separately. You give like the differences together. Okay. Okay. Any questions about this introduction, thermocouple? Okay, no questions, eh? Okay. So let me continue this. You can take down. It's recorded, right? So you can view. Okay. Let me ask you one question about thermocouple. One question about the calculation. Okay. Let's see how well you adapt to the idea. Okay. Let's say you have one thermocouple. Okay. I draw this. This is 0 degrees Celsius. This is 100. Okay. The reading is 5 millivolt. Then I put another one. Okay, like this. Here's 0 degrees Celsius. Here is theta, but the reading shows negative 3 millivolt. Negative. What is the temperature of theta? Okay, 1 minute for you. This is the technique I told you. Calculate for me. You can send me the answer. WhatsApp me. 0 to 100 is 5 millivolt. 0 to theta is negative 3 millivolt. What is the value of the theta? What temperature do you think should be? Please WhatsApp me the answer. Yeah, good. So only two of you replied me. The others. Yeah, okay. So all of you giving me the same answer. Good. 4 of you. Okay, negative 60. Yeah, good. So you got the idea. Negative 60 degrees, right? Negative 60 degrees Celsius. So theta equals to, sorry, in this case, V theta minus V naught over V 100 minus V naught times 100 degrees Celsius. V theta minus V naught is found to be negative 3. You put the negative inside, 5 times 100. Yeah, so theta immediately get negative 60. Yeah, correct. So this is how it works. Okay. So remember in exam they will ask you which wire is which. This is wire A means this also wire A. This is a different wire, wire B. Okay. Okay. So now let's see advantage and disadvantage of this thermocouple. Okay. So this is the thermocouple looks like this. It consists of two wires. One junction is placed where the temperature is to be measured, and the other is kept at a constant lower temperature, 0 degrees Celsius. The measuring instrument is connected in the electric circuit. The temperature differences causes the development of electromotive force. EMF will be generated. That is approximately proportional to the difference between the temperature of the two junctions. The temperature can be read from standard table or instrument can be calculated to display the temperature directly. Okay, now the current one is directly give you the temperature. Okay, it's already programmed. Okay. Okay, so advantage, disadvantage, we go to this table. The D is thermocouple. Okay, the range is quite same as the constant volume gas thermometer, up to 1500 degrees Celsius. The advantage and disadvantage, the advantage is wide range, same as constant volume gas thermometer. The touching point is very small. You know, the metal going to touch the body is very small, so it's useful for both local and rapidly varying temperature. And this is the main advantage of thermocouple. Okay, it's very useful for both local and rapidly varying temperature. Local means like a very small surface area, like you know the a small water droplet on the leaf. I think the best to find temperature of this water droplet is thermocouple, because the metal is too small, it can touch the water, okay, precisely, and that's why thermocouple can be used. It's local and rapidly varying temperature. This is main advantage. Rapidly varying temperature. What is meant by rapidly varying temperature? Let's say you do an experiment in the lab, maybe water, okay. So you want to find the temperature of this water every 1 minute. You want to find the temperature of this water every 1 minute accurately, okay. Or maybe you want to find this temperature every 30 seconds, okay, short period of time, okay. So the best thermometer can be used is thermocouple, okay. Why thermocouple? Because it seems it achieves thermal equilibrium very fast, okay. Thermocouple achieves thermal equilibrium very fast, okay. So that's why it achieves thermal equilibrium very fast. So 30 within 30 seconds, the new temperature of the water, the thermocouple able to show that new temperature, okay. Like for example, mercury in glass take time to achieve thermal equilibrium. You can see the temperature still rising, okay, and not really accurate mercury in glass, because it has a thick glass outside. The glass will absorb some energy, so not that accurate, okay. So thermocouple used for rapidly varying temperature, okay. Yeah. So like a car engine temperature level, thermocouple to be used. Okay, every single timing change, the thermocouple can measure the temperature for the engine, the car engine. Thermocouple is used. Okay, the most accurate thermometer less than 100 degrees Celsius. The only problem of thermocouple is it more than 100 degrees Celsius is very accurate. Less than 100 degrees Celsius said to be not that accurate. Okay. But still okay. I think can say thermocouple is almost perfect, but not as, of course, not as accurate as constant volume gas thermometer. And constant volume gas thermometer is the number one accurate, number one ranking in accuracy. Okay, thermocouple is quite close to accuracy. Okay, but not as good as constant volume gas. But very famous because it's unique way of getting the thermometric property, because you can't read the L0, L100 separately. It will be in like in pair, and it uses for rapidly varying temperature. Other thermometers can't really do that. Constant volume gas can do, but it's bulky. That's why we never use it. Mercury in glass, not that accurate, although it's varying quite fast, but not that accurate. Platinum resistance, we will come back to this after this. Okay, so that's thermocouple. What type of thermometric property used by thermocouple? Potential difference, or you can say electromotive force, EMF. The EMF between the junction is the thermometric property. Any questions so far? Thermocouple. Okay, so finally we go to resistance thermometer. Okay, resistance thermometer is its outfit going to be about the same as the thermocouple, but it measures resistance, the resistance of the wire will change according to the temperature. Okay, so it measures resistance. It takes the resistance of the wire change according to the temperature the body touches. Okay, the measuring element of the resistance thermometer is spiral in fine wire. It was greater size and heat capacity of the thermocouple cannot therefore measure the rapidly changing. This is the main disadvantage. The second paragraph is the main disadvantage of resistance thermometer. The wire used to measure the temperature has a very heat capacity, greater size and heat capacity. So it's a very high heat capacity. Okay. We haven't learned about heat capacity yet in A levels. We'll be learning that in another 2 topics ahead, topic 5. But I believe you learn in O levels. You learn specific heat capacity, right? It's about the same heat capacity. If big heat capacity means, what is the disadvantage? If the thermometer has a very big heat capacity means, what is the disadvantage? Okay. Let me go back to the whiteboard. We're going to talk about the heat capacity. Let's say you have liquid which is, let's say, it's 80 degrees Celsius. You put a normal mercury in glass thermometer inside. Okay, let's say originally the mercury in glass was room temperature 27 degrees Celsius. Okay, when the thermometer is placed into this water, thermal equilibrium will start to achieve, right? It takes time for the thermal equilibrium to achieve. How thermal equilibrium is achieved? Some heat from the water must be absorbed by the thermometer so that it rise the temperature from 27 to 80. To 80, I suppose to go for 80. But because in the process of thermal equilibrium, before it achieve, what happened? The water, which is 80 degrees Celsius, the thermometer absorbs some energy of the water, right? You need to absorb some energy of the water. So in that process, what happened? The water temperature from 80 will start to drop, maybe to become 79 degrees Celsius, because some energy has been absorbed by the thermometer. Okay, when the energy drops, the temperature will drop, right? So this thermometer will take some energy, and until final temperature is supposed to be 80, but the thermometer going to read maybe 79 degrees Celsius. That means the thermometer altering the temperature of the body. Because of what? For the sake of thermal equilibrium to be achieved, some energy need to be absorbed by the thermometer from the body you want to measure the temperature. Okay, but if this thermometer used as a very high heat capacity, if it has a very high heat capacity, what is the meaning of heat capacity? You learn about specific heat capacity, right? Specific heat capacity. Okay, what is specific heat capacity? We will do this in the topic 5, but for O level you learn, right? Specific heat capacity is what? E equals to mc theta, your heat energy formula. So C is your specific heat capacity, right? Specific capacity is what? The amount of energy required to rise the temperature of 1 kilogram of substance by 1 degree Celsius, right? Your O levels. Okay, I believe you learned this. So, okay, recall back. Specific heat capacity. If the specific heat capacity very high means, what's the problem? The thermometer, let's say, has a very high specific heat capacity. Means what? It's going to take, it needs lots of energy to rise the temperature by 1 degree Celsius. Just to rise the temperature by 1 degree Celsius, you need lots of energy. Okay. If this thermometer has a very high heat capacity means from 27 degrees Celsius to rise to 80, I think you're going to take lots of energy from the substance where you want to measure the temperature. Okay, you're going to absorb lots of energy from the substance. In this process, what happened? I think you need to supposed to measure the 80 degrees Celsius, but in the process of absorbing lots of energy, the body temperature going to drop a lot. Okay, the 80 degrees Celsius going to drop a lot. The 27 degrees Celsius of the thermometer going to rise. They'll meet up at the center, final temperature in between, and this the temperature will be in equilibrium, maybe at 78 degrees Celsius, let's say. So finally the thermometer is going to show you 78 degrees Celsius. Is it good or bad? It's bad, right? Because we thought we want to find 80 degrees Celsius temperature of the body, but because of the process of energy absorbed due to heat capacity, huge heat capacity. So if the heat capacity is very huge, the temperature going to drop a lot. Okay, so that's the point I'm like to highlight here. If you have a thermometer with a very high heat capacity, means it's going to need lots of energy to rise its temperature by 1 degree Celsius. So when equilibrium achieved, the body going to lose lots of energy. So the temperature of the body will be altered a lot. Okay, so this is not good because it's not accurate. We're not going to measure that. It's not actually measuring the temperature. It's altering the temperature of the body a lot. Okay, so the type of thermometer will be used if the thermometer has uh, preferably the thermometer we're going to use, preferably we prefer to have a very low heat capacity or very high heat capacity. We assume we be looking for a thermometer with a very low heat capacity. Okay, if a very low heat capacity, it just take little energy from the body to achieve thermal equilibrium. So the body won't lose much energy. So temperature of the body won't be dropped a lot. Okay, so the final equilibrium point will be quite close to the original temperature of the body. Okay, that's the heat capacity effect. Okay, so thermocouple, right? Just now I told you thermocouple. Thermocouple has a very low heat capacity. Thermocouple. Okay, so thermocouple won't alter the temperature a lot. Okay, but resistance thermometer, right? This resistance thermometer has a huge heat capacity. If it has a huge heat capacity, meaning what? You're going to absorb lots of energy from the body to measure the temperature. So therefore, it's not good to measure rapidly changing temperature. It can't use to measure rapidly changing temperature. Like for example, you have a water, you want to measure the temperature of that water, heating water every 30 seconds. This is not a very good thermometer because once you put the resistance thermometer inside, its capacity is very high. You're going to absorb lots of energy. You're going to consume more time also to achieve thermal equilibrium. Okay, so time taken to achieve thermal equilibrium also takes longer time. By the time 30 seconds, the resistance thermometer haven't achieved thermal equilibrium yet. So therefore, the reading portrayed is not the actual reading of that body at that moment. So rapidly changing temperature, the resistance thermometer is not good because there's a very high heat capacity. Okay. So this is bad, but then why we are learning this? What is anything good about this thermometer? Okay, there is a good. Okay, what's good about this thermometer is this thermometer is the best used to measure melting point and boiling point of a substance. Okay, so but over the range from about the room temperature, a few hundred degrees Celsius is more accurate. The platinum resistor thermometer is used for measure this temperature. It's best used for what? For melting point, melting and boiling point of substance. Resistance thermometer is used. Why boiling point can measure, melting point, boiling point you can measure accurately? You know, right? Why melting point, boiling point is the best? You know, right? If you have a substance, when you heat it, then when melting, it flat. Heating it, melting flat. So during melting point, let's say this is the melting point, there is a significant duration of time it will stay in that melting point temperature, the melting point. So you put a water which is changing phase from solid, it changed to liquid. It will have a certain duration of time. Maybe the duration is maybe 2 minutes for it to melt. So during that moment, if you put a resistance thermometer takes the energy. At the same time, it has enough time to achieve thermal equilibrium. So the temperature going to be given by the resistance thermometer, it's already achieved thermal equilibrium. Okay, so but the resistance thermometer, once it achieves thermal equilibrium, the reading the resistance thermometer gives seems very accurate compared to thermocouple. for melting point, boiling point, thermocouple. Once it achieves thermal equilibrium, means the reading you will give is going to be very accurate. Okay, the only problem is it's a very slow. It takes time to achieve thermal equilibrium. That's the problem. Like a person who are answering a question fast but wrong, but this guy really takes a very long time. But when he once he answer, like it's very accurate, precise. And that's resistance thermometer. Okay, so what is the advantage, disadvantage of resistance thermometer? Go back to this table. The platinum resistance thermometer is a wide range, best for small steady difference of temperature, steady temperature, melting point, boiling point. Okay, so you can put that. Melting point, boiling point, best is platinum resistance. The most accurate thermometer in the range of less than 600 degrees Celsius, but of course doesn't beat the constant volume gas thermometer. Disadvantage, not suitable for varying temperature. Why? Because it's a large heat capacity. It takes lots of time to achieve thermal equilibrium. Okay, because you need to drain out, you need to take out lots of energy from the body you want to measure the temperature. Okay, yeah, use the material of low thermal conductivity of shield. Okay, so this is the 4 types of thermometers. Okay, so where do you use mercury in glass? For clinic, fast reading, but not accurate. Where do you use constant volume gas thermometer? City temperature. Okay, but bulky, cannot move around. Okay, disadvantage. Where do you use platinum resistance? Melting point, boiling point of a substance. Platinum resistance is the #1 choice. Okay, thermocouple, the best for small bodies which has a very little energy, like as I said, a droplet of water on a leaf. Okay, a small space you want to measure temperature, maybe a part of the engine. In an engine, a certain part which is very close inside, you want to find the temperature, thermocouple is used. Okay, and used for varying temperature. Okay, so mercury in glass, what is the thermometric property? Length. Constant volume gas, what is the thermometric property? Pressure. Platinum resistance, what is the thermometric property? Resistance. Thermocouple, EMF, electromotive. So finally, you need to memorize this table. Okay. So any questions, guys, for today's lesson? No questions, So today we learn about this different type of thermometer. What is the thermometer property? What is plus and minus? Okay. So I stop here. So tomorrow we'll be discussing with the AS paper as usual. Okay, I hope you already done the AS prepared. So we discuss the papers. Any questions before I stop? No questions. Yes, thanks. See you back tomorrow.
Thanks, sir.